Hi everyone, today we are looking at creating pie graphs, and not just any pie graph, we are looking at creating accurate pie graphs where we are actually going to measure out what those pieces of the pies are going to look like. So we'll get into that in just a second. First thing we got to do is we got to figure out how big the pieces of the pie are going to be, and this involves a lot of math. So you do have to have some basic mathematical knowledge behind this. It involves some fractions, it involves changing fractions into decimals, it involves percentages, it involves knowing the how many degrees are in a circle. So there's a lot to it. So if at any point you feel like you need to stop and kind of re-watch a certain part, I highly recommend you please do so. Alright, so let's get started. So as you can see right here, I have a data set, and we're looking at kinds of flowers. One of the first things that you have to do is you have to figure out how many total responses there are. Now, luckily, this data set has already done that for me. If it hasn't, let's say that that wasn't there, so I'm just going to kind of eliminate that. I can determine it by just simply adding all of those numbers together. 1 and 5 and 5 and 4 and 9 added together will equal 24. That's an important thing, because what it means is that that 24 is the number 100% of the responses is what that equals. So if I was to travel all the way around this circle, I would end up with 24 total responses. Now that's a very hard concept for a lot of kids to understand because it sounds kind of confusing. That number can change, but essentially what it means is that 100% is equal to 24 in this case. So I'm going to eliminate that, and now how do we determine what the size of the pie pieces are? Well, it's actually really simple. We know that a pie piece, and that's an important term, piece, is actually a part of the whole, whereas this whole circle around is the entire thing. We know that a piece of it belongs to Rose. A piece of it belongs to Tulip. A piece of it belongs to Lily, and so on and so forth. Now, when we say a piece of a whole, that kind of reminds me of something. That reminds me of fractions, because a fraction is a part of a whole. Now, how big of a part are we talking about? Well, that's pretty simple. One of the responses out of 24 was Rose. 5 out of 24 was Tulip, and luckily Lily is the same thing, so I'm only going to do that once right here. This is going to represent the numbers that I need for Tulip and Lily. 4 out of 25 was Orchid, and 9 out of 25 was Forget-Me-Nots. So now that we have fractions and we know what the parts of a whole are actually going to be, how does this work? How does this matter? What does that fraction mean? Well, it's actually kind of simple. The part of the whole is going to give us how big of a percentage it is. So if I was to look at the Rose section and I was to figure out, okay, if I scored 1 out of 24 on a test, I got one part of 24 possible answers. That's not a good mark, by the way. What do I have in total? What is that percentage equal? So sorry about that ring, trying to record in the classroom. So what I'm saying is that what I need to do here is take the top number and divide it by the bottom number, and that's going to give me a percentage. And it's a percentage of what that piece of the circle is going to be. So if I take 1 and divide it by 24, I get a decimal. I get decimal 041, 041, which is equal to about 4%. So 4% of this circle is going to be dedicated to Rose. Now let's do the same thing with the rest of these. 5 divided by 25, well, that's 20%. So 20%, now decimal 20 is the same as 20%. So 20% of the circle is going to be Tulip, and 20% is going to be Lilies. So there's two 20% there, just don't forget. I only wanted to do the calculation once though. And then if we look at 4 divided by 25, we end up with 16, decimal 16, which is 16%. And then finally our big one, we got 9 divided by 25. 9 divided by 25 is decimal 36, which is 36%. Now, if I were to take and add all of these percentages together, they're going to equal 100% of the circle, because I took all of these pieces, these parts, and I added them together, found the percentage, and they were the parts of that whole, which is 24. I'm going to kind of clean this up a little bit here and get rid of some of this nonsense. Okay, so now what do we do with these percentages? I mentioned just a second ago that these are the percentage of the circle. So 36% of the circle is going to be forget-me-nots. So how do I determine what the size of the pie piece is then? Okay, well that's relatively simple. What I need to know is that decimal 36 is the same as 36%, and I'm going to multiply it by the circle itself. Now, when we measure a circle, we measure in degrees. And if I was to travel all the way around the circle back to here, I've traveled 360 degrees, or 100% of the circle. So I'm going to take 36% and I'm going to multiply it by 360 degrees. 36% of 360 degrees. So if I take 36% and I multiply it by 360 degrees, I end up with 129.6 degrees. Now, that is something that I can definitely use. So if I go into here and I grab myself a protractor, shrink this down to the size of my circle, give it a little bit of a twist, starting from the center of the circle, I can find where 129.6 degrees would be, and this is a small protractor in a small circle, but I can see that it's probably going to be somewhere about this area, right about there-ish, and that's obviously 0 to center, and then my pie piece will come out like that. Obviously you would use a ruler and not your finger like I am, because this is not going to be 100% accurate. And what I've got here now is the size of my pie piece. 129 degrees of this pie is going to be dedicated to forget-me-nots. So this is what you're going to do. You're going to take that protractor and then make this your 0 line, and then measure the next one, 20% of 360 is going to give you a certain amount of degrees. And another 20% is going to give you that same of 360 degrees. And once you have all of those degrees, you're just simply drawing the lines using the protractor all the way around. And that's how you solve pies. I would do it right now, but I'm running short on time. My bell's going to ring here momentarily. So if you want to rewatch this video, take a look. You're more than welcome to leave some comments below, ask questions, that kind of thing. If it's not clear, I'll definitely try and do a different video to make it sound a little bit more concise. But this is what you're going to do for pie pieces in order to solve this. So I'll just write out some steps here real quick. Step 1 is that you want to find the total. Find the total responses. And then step 2 is you're going to create fractions, which is pieces out of the whole. So the whole responses. And then step 3 is you're going to find percentages. Or decimals, because you're going to use the decimals when you actually do your stuff. And then step 4 is you're going to take and go take your percentage and multiply it by 360 degrees, which is going to equal the pie piece size. And then, that was step 4. Step 5, use protractor. To measure a round circle. Ooh, my writing is not that great, especially when I'm doing it from a finger on a vertical iPad. To measure a round circle. Alright, that's it. So 5 steps, and that's all you need to do in order to solve pie graphs. If you have any questions, let me know.